Hi, I'm Matt, and in this video we are going to go over how to determine an atom's oxidation state. So an atom's oxidation state, or oxidation number as we're going to refer to it, represents the amount of electrons that an atom has either lost or gained in a compound. So if the atom lost electrons, the oxidation number is positive. Generally, metals or nonmetals with low electronegativities lose electrons. And if an atom gained electrons, the oxidation number is negative. Generally, nonmetals and metals with very high electronegativities gain electrons. This may seem backwards that if we lose electrons, we're positive, and if we gain electrons, we're negative. But keep in mind, electrons have a negative charge. So if we have more of them, we're more negative. And if we lose them, it's a double negative, making the atom more positive. So now, how do we determine the oxidation state of each atom in a compound? So first, if there's a metal, its oxidation state is going to be equal to its ionic charge. So for example, if we have potassium, which forms K+ ions, it has a +1 ionic charge, so it's also going to have a +1 oxidation state in the compound. When it comes to the negative charges, the most electronegative atom in the compound generally will have the negative oxidation state. So for example, in KCl, the chlorine has a -1 charge or a -1 oxidation state. In an atom, all of the oxidation states must equal 0 when we add them up, or if we have a polyatomic ion, they have to equal that ionic charge. And the last thing to note is that atoms by themselves have an oxidation state of 0. So if we have pure calcium, Ca, or pure iodine, I2, it's going to have an oxidation state of 0. To further help us determine an atom's oxidation state, we have some always rules that we could always assume when we do the questions. So the first one is that group 1 metals, such as lithium, sodium, potassium, and rubidium, always have a +1 oxidation state. Group 2 metals, such as beryllium, magnesium, calcium, and strontium, will always have a +2 oxidation state. And the last rule that's always true is that fluorine will always have a -1 oxidation state. The next set of rules we're going to go over are sometimes rules. They usually apply, but they have some exceptions to them. So the first is oxygen. Oxygen will usually have a -2 oxidation state. The only time it doesn't is when it's in a peroxide and then it has a -1 oxidation state, or in the compound F2O, where it has a +2 oxidation state. Chlorine usually has a -1 oxidation state. The only time is when it's combined with oxygen and or fluorine, and then you'll have to use the others to determine what it is. And the last sometimes rule is that hydrogen usually has a +1 oxidation state. The only time it doesn't is when it's combined with a metal in a hydride, and then it will have a -1 oxidation state. So we're going to use these rules to try some examples. So for our first example, we're going to look at ammonia, or NH3. And the first step in any of these is determining what always and sometimes rules we could apply. So the only one we could use here is that hydrogen always has an oxidation state of +1 when it's combined with a nonmetal. Nitrogen is a nonmetal, so we know that hydrogen has an oxidation state of +1. Now that is, each hydrogen has an oxidation state of +1. So since there's 3 of them, that together gives us a charge of +3. Now, since NH3 has an overall charge of 0, all our oxidation states must sum up to 0. So we could write that as something, I'm going to use a question mark, +3 equals 0. And solving for that question mark will give us -3. That means that for all the oxidation states to sum up to 0, nitrogen must have an oxidation state of -3. And if we wanted to, we could write the compound to show all those oxidation states by putting a superscript of -3 next to the N and a superscript of +1 next to the H. For our next example, we're going to try calcium carbonate, or CaCO3. So, like always, we're going to start by looking at our always and sometimes rules. First, we see Ca, which is a group 2 metal, so we know that its oxidation state will always be +2. And then, there's no fluorine and no peroxide, so we know that oxygen will have to have a -2 oxidation state. And there's 3 of them, so we multiply that to get -6 in total for the charge. So now, all that's left is to find the oxidation state of carbon. So we're going to use the same strategy as we did in the last problem. We're going to do -6 from the oxygen, plus 2 from the calcium, plus question mark for whatever carbon is, equals 0. And combining gives us -4 plus question mark equals 0, and that gives us that question mark equals 4. So the oxidation state of carbon is +4. For our next example, let's look at K2Cr2O7. Potassium is a group 1 metal, so it will always have an oxidation state of +1. And there's 2 of them, so that gives us that there's +2. Oxygen will have an oxidation state of -2 because there's no fluorine and this isn't a peroxide. So we do -2 times 7 since there's 7 of them to give us -14. Next, we need to find the oxidation state of chromium since we don't have a rule for it. Now, it's important to note that oxidation state refers to each chromium atom, not the total amount between the chromiums. So when we write our equation of +2 minus 14, we're going to have to make it +2 question mark because there's 2 chromiums. Solving that will give us that 2 question mark equals 12, or that question mark equals 6. So the oxidation state of each chromium atom will be +6 in this compound. We're going to try another example now where there's multiple of each element. So fluorine will always have an oxidation state of -1, and we have to multiply that by 10 here since there's 10 fluorines, which gives us an overall charge of -10. So what will the oxidation state on sulfur be? Remember there's 2 of them, so we have to write 2 question mark minus 10 equals 0. Working through that, we get that question mark equals 5. So each sulfur atom has an oxidation state of +5. For our last example, we're going to look at an ion instead of a neutral atom. So we're going to look at ClO3-. So oxygen will have an oxidation state of -2 here because there's no fluorine and it's not a peroxide. So we have to do the -2 times 3 because there's 3 oxygens to get -6. Now, what is the oxidation state on chlorine? Now, some of you may be thinking -1 because that's on our chart. But remember, there's an exception to that when we have oxygen, so we're actually going to have to work out what chlorine is here. So we're going to write question mark for chlorine plus a -6 equals -1. Here, we wouldn't set it equal to 0 because this isn't a neutral atom. It's a negative ion with a -1 charge, so that's why we would set it equal to -1. Adding 6 to both sides gives us question mark equals 5, so the oxidation state of chlorine in the chlorate ion will be +5. Now that we've worked through some together, I encourage you to try these practice questions. For all 5 of them, I would like you to determine the oxidation number or state of each number in them. At this time, I suggest you pause the video and the answers will be provided for you on the next slide. The solutions are as follows. In KMnO4, potassium has a +1 oxidation state, manganese has a +7 oxidation state, and oxygen has a -2 oxidation state. In question 2, Cl2 would have a 0 oxidation state because it's a pure atom and isn't actually in a compound. For question 3, hydrogen had a +1 oxidation state, Cl had a +3 oxidation state, and oxygen had a -2 oxidation state. For question 4, C or carbon had a -3 oxidation state, fluorine had a -1 oxidation state, and hydrogen had a +1 oxidation state. And for the last question, phosphorus had a +5 oxidation state, and oxygen had a -2 oxidation state. Hopefully you got these. If not, feel free to leave any questions you have in the comments below. Thank you so much for watching. Have a great day.